In this chapter, we will have discussion about the some fundamentals concepts of the memory management, and we will have discussion about swapping. The background concepts and the swapping concepts are already clear to you guys because in our previous multiple lectures we had discussion about these two things. Okay, you will find some new things here too in these two topics when we will discuss them. Third topic will be about the memory allocation, that how the system will allocate memory to a particular process when they want to execute and they want to load from the back storage to the main memory. How the memory will be allocated to them. The fourth is about segmentation, and this is about paging. So these are the memory allocation mechanisms. Okay, these are the very common and most famous mechanisms, segmentation and paging. Both of them will be discussed in this chapter. Dear students, some of the topics will be covered in today's lecture, and I'm sure that these two will be covered in the next lecture. Okay. Okay, guys, let's continue. The objective of this chapter will be to provide a detailed description of various ways of organizing memory hardware. Dear students, here we will talk about the memory like main memory. Okay, how they will be organized and how they will be allocated to different processes. We will discuss various memory management techniques, including paging and segmentation. As I told you before that the paging and segmentation, they are memory allocation and memory management techniques. Okay, we will discuss them in detail. And we will also discuss that how the segmentation and paging or segmentation with paging will be handled by some of the processors, okay, like Intel. So these were the objectives of this chapter. And let's start from the memory management. As you know that I tell you about the contents in the second slide of this chapter, that we will have some background or some fundamentals concepts about the memory management. So now we are in those fundamentals concepts. So in those fundamental concepts, first of all, we will have discussion about the definition of memory management. Dear students, memory management is the functionality. Remember, memory management, it is a functionality, okay? And this is the functionality of an operating system. It means that operating system is responsible for the memory management. But remember, if you remember the hierarchy of memory, we are not talking about the cache memory or register memory, because for the cache and register memory management, operating system is not responsible. Operating system is not responsible. What is responsible? Processor. But if you have main memory, if you have your primary storage or secondary storage, for both management, the operating system is responsible. That's why we are saying that memory management is the functionality of an operating system, which handles or manages primary memory. Specifically in this chapter, we will focus on primary memory. Primary memory means our RAM, okay, which is our main memory or primary memory. Remember, the RAM is also known as a primary memory or is also known as a main memory, okay? And in this functionality, the operating system will do these things like keep track of each and every memory location, because you know that our main memory will be divided into multiple memory location. Every single location or part of the memory where the bits can be stored is called a memory location. Remember, memory location can be any place where the bits can be stored. So they are called what? They are called memory locations. And here the operating system is responsible to keep track of each and every memory location. If it is allocated or if it is free. Let's suppose this is our RAM and this much RAM is full and this much RAM is free. For example, this is my free amount of RAM. But the operating system should keep track of this thing, that how much memory locations are free here and how much memory location are allocated here, okay? It check how much a memory is to be allocated to processes. It's also check that how much memory will be allocated to a claim process. It decides which process will get memory at what time. It's also decide that which process will get memory at which time. It must be also decided by the operating system. It track whenever some memory gets freed, and also it should know that when the process will release their memory or how much memories are unallocated, and correspondingly it updates the status. So it means that the operating system will have a complete database. They will have a database. In the database, there will be complete information about the memory, that how much memory is allocated, how much memory is free. Free mean unallocated, okay? How much is demand, and how much is going to be released, okay? Is going to be released. Because as you know that in the deadlock avoidance, we discuss that the system have what? A database, a prior information. So same like that, dear students. The operating system must have a prior database about the memory, but if the operating system don't have a database about the memory, then remember, the OS will not able to manage the memory. It is very much necessary to take the optimum decisions, right decisions. For that purpose, the OS must have a database or information about their memory. And this information management, and based on that, making some decision like allocating resources, like getting back those resources, is called what? Memory management. And also, which process should store in which memory location, okay? And how they will store. All these things are belongs to memory management, for which operating system is responsible. Okay, guys, we know this, that our data will be stored in the hard disk. When they want to execute, so they will first go to the CPU. Let's suppose our CPU. They will first go to the CPU, and the CPU will release a memory address. And after that, the process will come and they will be allocated. The memory will be allocated to the process. Let's suppose there is a application. The application want to become a process. So, okay, so they will go to the CPU, and if you study the computer architecture, then you can know that how they will interact with the CPU, why the multiple buses, okay? So they will come to the CPU will assign an address, a register address, and this address will be taken by the OS. And based on this address, the OS will allocate them a particular memory in this main memory. So based on this normal procedure, we can say that program must be brought from the disk means the hard disk, into memory and placed within a process for it to be run. It will become a process and they will be run. Main memory and registers are only storage CPU can access directly. Remember, the CPU can access your cache memory, your register memory, and even the main memory. The CPU can access any part of this memory. They can access any part of the memory. That's why we call it random access memory. They can access this part of the memory, they can access this part of the memory, any part of the memory randomly, okay? So that's why we can say memory unit only sees a stream of, okay, a memory and register are only storage CPU can access directly. Dear students, in the CPU, we have a particular unit which is called Memory Management Unit, MMU. MMU is a unit which is responsible for address issue. They will issue the address and they will keep the addresses with themselves. Whenever the process wants to access a particular process, so this memory unit will give them the address, and then based on the address, the process will be targeted in the particular memory location. So based on this, we can say that the memory unit only see a stream of addresses. A stream of what? Address. It means that this memory address will just only handle the addresses. That's why we call it seams, mean that they will just only observe, read, write the addresses. Stream of addresses plus read request plus address plus data and write request. Whatever interaction is going to take place, and they will need a particular address. So the address will be assigned by the memory management unit during reading, during writing, and in every circumstances. Register access in one CPU clock. Dear students, these are the background information. That's why we are not focusing on specific topic, okay? These are like bullet points. The fifth thing is that, this is the fourth thing, yeah. Register access in one CPU clock or less. You know that the CPU have what? The CPU have register memory. And this register memory will be accessed in one CPU cycle. One CPU clock means one CPU cycle, okay? Cycle, remember, CPU is something analog, okay? That's why they will complete their cycles. Like for example, you have 2.0 gigahertz processor. It means that your processor can complete 2 billion cycles in 1 second, okay? Main memory can take many cycles using a stall, yeah. But the main memory will require many of the cycles. It means that the main memory is slower than the register memory, so multiple cycles will be required to access main memory location. And this multiple, it will cause what? A stall, okay? It means that multiple cycles will create a stall, and a stall, a memory address will be accessed from the main memory. And you know that the cache memory will be set between register memory and the main memory to make it a little bit faster. For example, register memory is the fastest memory in the CPU, where the main memory is slow memory compared to register. So when a CPU comes from the register memory direct to the main memory, for example, this is my CPU, and there is register memories, okay, and this is the main memory. It is the fastest memory. And this is slow memory. So when the CPU want to take a particular address and they want to based on that address to a particular memory location, you know, they will need multiple cycles. Multiple cycles. And multiple cycles, it means that the CPU should access the particular address after a long time. After a long time mean, sorry, not after a long time, it means in a long time. Okay, they will take more time. So it is good to bring these things to this middle memory, which is called cache memory. Okay, so whenever the CPU want to access those data or those applications, when they will run simultaneously or when they will run or required continuously, So the CPU will no need to come to the main memory. They will directly access them from the cache memory. They will be here for the temporary basis. So it means that it will decrease this round trip time. They will decrease, the cache memory will decrease what? This round trip time. Let's suppose if here a 1 milliseconds was taken, so here maybe a 1 microsecond will be taken. Okay, for example. Why? Because the cache memory is faster than the register memory. Okay. Now we have to understand the base and limit registers, because this is something very much important. Based on this, the memory protection will be done. Who will do the memory protection? Operating system. First, let me define what is memory protection. Dear students, for example, I have a RAM, and let's suppose my RAM is 100 megabytes. The RAM size is how much? 100 megabytes. And this much memory is already full. Maybe by OS or maybe by some process like P1 and P2, for example. Okay. And suddenly, after these two processes, P3 is arrived. P3 want to load here. They come to the CPU issue an address, and based on this address, the memory will be allocated here. But let's suppose the CPU issue that this process will require 1 MB memory. Okay, now the OS, shall the OS store this process here in the place of P2 or in the place of P1? Indeed, they will do this if we don't have memory protection. If we don't have memory protection. But now we have memory protection, the OS will not do this. The OS will store it here. The OS will store this process here. And this is called what? Memory protection, because this area is protected. This area is being protected from this new arrived process. This old processes will be not replaced by the files of new process. This new process will be stored in a free memory location. But the thing is, okay, based on what? Based on memory protection. And now let's understand how the memory protection will work. In order to protect the memory, the operating system will use two addresses. One is called base register, another is called limit register. Okay, so it's a pair of registers. The base registers hold the smallest legal physical memory address, and the limit register specify the size of the range. Let's assume this is my memory, start from here and finish here. Okay, up to this much area, it is held by the operating system. Okay, so this is called the limit register for this operating system file. But this is a base register. Like when the base register is going to be created, this will be the base register 256001. One register on one memory location upper. So this is the base register. Forward for this process. And this will be the limit register for this process. Where the limit register is what? 3004. Okay, but let's suppose this is process 1 and this is process 2. But for the process 2, this memory, which was a limit register for the process 1, with one increment like 3 0 0, yes, not sufficient place. Yeah, let's suppose here 1 4 1 and 3 0 0 4. So this will be the base register forward for the P2, and this will be the limit register for the P2. No, it's not the limit, it's the limit. Okay, limit register for the P2. So dear student, this is called what? The base. That's why I told you that the base register hold the smallest legal physical memory address. Smallest mean the lowest portion of the particular process, which is the 3001. And the limit mean specify the register, the size of the range, that how much memory will be held by this. And you can see here. If it is confusable, don't worry, let me make it very simple for you guys. Let's take in our example. Our memory was how much? Our memory was 100 megabits per second. So let's suppose the 50 megabits per second is occupied by the 0, from 0 to 49. So now the 0 is what is base register of the OS. And this 49, yes, 49 is limit register. Okay, and now for the P2. For P2, the 50 is a base, and let's suppose they occupied 5 MB, and 55, okay, 50, 51, 52, 53, 54, it's not 55, 54 will be the limit register for P1. Okay, it's done. For P2, this point, which starts from 55, will be the base. And let's suppose it's occupies 7 MB. So 7, you can count it 55, 56, 57, 58, 59, 61, and 62. 62 will be the limit register. So based on these two addresses, the memory protection will be made. Okay, is it clear, guys? Yes, because it's very easy. Okay, guys, so logical and physical address space. So the logical and physical address space, you will understand this based on the limit and space, based on the limit and base register. Okay. So guys, logical address and physical address. Logical address is generated by CPU, where the physical address is location that exists in the memory, It's very simple. Come back to your slide, whiteboard. Dear students, it's time to focus and understand this logical address. As we studied before that, the P3 is arriving. Okay, P3 come to the CPU. The CPU issue that 1000, let me make it simple, 1 megabyte memory should be allocated to this. So 1 MB. This represents what? Size of a memory. Okay, but we don't know that this 1 MB will be where? This 1 MB will be where? Is it this will be here? We start from which base? Their limit will be what? We don't know anything about that. And such type of address is called what? Logical address. So this address is called what? Logical address. Masalan, Shuma, for example, yakasira address में थे मतलब एक नफर शुमा let's suppose best example चीज़ों में तो या for example let's suppose शुमा एक plot में खरीदा एक colony, okay, so you will contact with the property dealer and they will give you that there is a plot number 1005 is free, so you will have 1005 but they will say that this 1005 have 400 square meter space. So see, these are logical addresses. You don't know that this 400 square feet will be where? Is that will be at the middle of colony? Is that will be at the edge of colony, or at the front or back of colony? You do have no idea about that, but just the address is issued. So this is called what? A logical address. So same that that 400 square meter is representing a particular area, a size of the area. So same like that here, this 1 MB is representing a size, that how much size will be assigned to this P3. But it's not representing any memory location. It's not representing any memory location because I cannot tell you that which part of the memory will be this. So dear students, this logical address will be submitted to the operating system, to the OS, and the OS will convert this to physical address. The OS will convert it to physical address. How? The OS will see that I have free memory onward 62. Onward 62. It means that the limit is with me is 62. So let's occupy this here. So their memory, look, the P3 will be now 63 up to 64. It means that 64 is still free, okay? It means that the 63 address will be their base and this will be the limit. So now this base and limit both will represent what? Physical address. Well, physical address. Just like the person who will escort you to the particular colony and they will show you a location that this is your location and this is at the middle of colony. You are the neighbor of these people, so you know they will give you the exact location and you will stand on the exact location, and based on your neighbor addresses, your middle address will be your exact physical address. So same like that, once the memory is allocated and the process load to the memory, that address which is representing by the base and limit will be the physical address, and the physical address will give a memory location. Okay guys, so this was the physical and logical address space. Yeah, so the same thing is here. Let me explain this. First this. The CPU issue a logical address 346 to a particular process. Okay, so here is a MMU, memory management unit. So the memory management unit have the limit address. This limit address is assigned by who? By this OS, okay? This is still to the OS. Do you remember I told you before that the MMU will just only deal with the addresses? Yes. Okay. Okay, so OS is capture this limit address of 4000 submitted to the MMU. So the MMU map this. Remember, this is called mapping point, okay? The 346 is mapped over 400. The result is what? The result is physical address. Now, this is what this is a physical address. And this physical address is saying that the new memory, which is, let's suppose this is belongs to P5, there it start from what? It start from 4001 and finish on 4346. مثلا شما میگنی یک نمره زمین یک نمره زمین شد شما کجا در اینجا لیمیت بود اینجا خالی بود بعد از اون شما گرفتی این مکمل ساید شما شد. So same like that, you know, this was your limit register of the previous. It mapped over your logical address and you got a physical address where your physical address is 14346. And this is what? This is a mapping point. Who will do the mapping? Mapping will the MMU will do the mapping. What is mapping? Mapping mean mapping the logical address or the physical address. Okay guys, so as I told you before that the memory mapping is a process. Memory mapping is the translation or interpretation you can say it's a process of translation and repetition between the logical address space and physical address space. And the objective of this process will be to translate from logical address to physical address and to aid in memory protection, to do the memory protection, and to support the memory protection process, to enable better management of memory resources. It means that we will do for these three purposes: the memory mapping. As you guys saw, the memory mapping in this diagram. So why we are doing this? Mapping of this logical address or this physical address, okay, because of those three objectives: to translate from logical to physical, to add the memory protection, and to enable better memory management. Okay guys, so this memory mapping is also called memory binding. It's also called what? Binding. Binding means logical address space. Binding, okay? Binding to a physical address space. So let's talk about their time, that in which time they can happen, or in which stage can this memory binding can happen. It is possible to done memory binding at the compile time of a process, at the load time of a process, or at the execution time of a process. You know what is the compile time during their compilation? Load time, when it's going to load from the backup, from the back storage to the main memory. And maybe in the execution time, let's suppose if a process is already executed and they are in the main memory, but they call some their library functions, or they call some their other routines from the backup, from the back storage, from the hard disk. So it means that the process is already loading. And already loaded, they are in the running stage, and they are calling their more functions or routines, and they will load from the hard disk to the main memory. This is called execution time, okay? And at the execution time, the memory binding will be done, like new logical addresses will be released, and those logical addresses will be mapped to the physical addresses. So dear students, the mapping or memory binding is possible at three stages. When a program is going to compile from, they will compile from this, they will be run, compile, and the memory addresses will be mapped when they will going to load, or maybe in the execution time. If you guys are good in the programming concept, so then you can easily understand the compile time, because the compile time is related to programming, okay? The load time, execution time, it's belongs to the normal routine work. Like for example, you are going to open Microsoft Word, so they will load from the secondary storage to the main memory. At this time, the memory mapping will done. Or for example, let's suppose if you already run a particular program, they are in the main memory, but you are going to load their further modules. So for loading their further modules, they will call their more routines or functions, and when they will load, the memory mapping will be done.